In this video, we return to the same example we used in Euler's method spreadsheet lab, and we are going to use the spreadsheet to implement the improved Euler method, as seen in section 3.2 right here. And if you scroll down and go through the discussion, examples 1 and 2 here correspond to 2 and 3 that we did back when we learned Euler's method. So we're going to go ahead and try to implement, again, using the same function. So y prime is negative 2y plus x cubed e to the negative 2x, and y of 0 is 1. But what we're going to do now is we're going to implement the improved Euler method, where you actually take an average slope, in a sense. So we compute the slope as we would in Euler's method, and we're going to call that k1. And then we compute k2, which is a different slope. And we use, if you look at this, you're taking the average of those slopes, so 1/2 the sum of the slopes times the step size h. And so I'm going to try and implement this form of improved Euler in the same spreadsheet that we used earlier. I already have the function. I already have x, y, and a column for slope. By the way, I'm going to label this right here for my own reference, K1. And maybe I'll make it bold. It's a label. And that's going to indicate to me that, yeah, we're doing, and you know what, I'm going to slide this down one just to create a little more space. And that's going to indicate to me that this is an intermediate computation. I'm also going to need, if I go look at the book again, I'm going to need K2, and that means I have to do f of x plus h and y plus h times K1. All right, so I'm going to need 2 more columns here. Let's do it here. Let's create a column for x plus h. So that'll be here, x plus h, and let's create a column for y plus k1 times h. Now again, these are just labels. This is not actual computations yet. Let me go ahead and do something really cool. I want to get this same green look that we had earlier. And here I have, it's called paint format. And so it uses exactly the same formatting that you have right here. So I'll click on that. And notice this is highlighted. And I'll go over here and it's going to take care of the centering and the bold. And actually right here will not be bold because this is not. So this is really kind of nice. All right. So how are we going to get x plus h? Well, we're going to say that this equals the current x value plus, now remember h is the step size, so I'll want to use C4, but I think it would be smart to make it $4, so that when I copy the formula down, it's going to keep pointing at the same square. Oh, they know what I want to do. Sure, I'll say yes. Go ahead and do that. So notice this one is A9 plus C4, whereas that's where D9 is, and D8 was A8 plus C4. So far, so good. And now I'm going to go ahead and compute this, y plus K1 times h. And the reason I'm doing this, again, let's take a look at the formula. The second slope we compute is going to be f of xi plus h and yi plus h times k1. So I need to compute this, yi plus h times k1. And that's what's going to go here. The way it's written, maybe I should write it that way. H times k1, just so that I match the book. I mean, it doesn't matter, but it's kind of nice. So let's go ahead and say that this formula, this cell is going to equal the y value plus And now again, for h, I want to use $4 times, and then K1, that's this cell, C8. Enter. And now it says, hey, I think I know what you want. Okay, I'll let you try it. Did it work? Yeah, it's doing B9 plus C4 times C9. So this is working out nicely. Okay, looks like I might need a little more room here. Okay. So now, let's see. We're going to compute K2. And what I'll do is I'll copy this here right to F6 and the cells below it. Let me double click and just kind of check, did this work? Well, first of all, this is going to be K2. It is a slope, but it's not f of xy. It's f of x plus h and comma y of, well, y plus, it was k1 times h. So that's the new slope, k2. Okay. And again, I can check the book just to be sure that I have that right. Make this a little bigger. Here it is. X plus h and y plus h times k1. Again, looks like I reversed it. I'll do h times k1 for my own benefit. Okay. And now, did this work correctly? Well, it did. Yes. X plus h, this purple cell is taking on the role of the x's. So it's doing x cubed, and it's doing e to the negative 2x. And E8 is the y value. So I'm using the correct y value there. So everything seems to be correct. And now, what we want to do is we want to get the new y value. So let's look at the book again. And the new y value is equal to the old y value plus the average of k1 and k2 times h. So let's get that. All right, so this is the new y value. So let's see. What I'll do is I'll call this new y. That's going to be the new y value. And so how does this work? Well, here, let's get the formatting. Use the format painter again. So I'm going to go ahead and make this nice. Put it here. Okay. Let's make this a little wider. And now, how does the new y work? The new y is equal to, and again, looking at it, it's the old y. Well, the old y was right here. And then plus h over 2, well, I can do it here, h over 2 times k1 plus k2. So plus, remember that h is this $4 times, and it's, well, maybe I'll say divided by 2, and then times, and here's where we need k1 plus k2. Well, k1 was this, the negative 2 in C8, plus, and k2 we just computed here in F8. And so that's the formula I want. That's the new y value. And sure enough, the new y value is here. If I copy it down or use autofill. Now there is one issue, and that is that this is not the y value I want, 0.8. What I want to use here is that y value. So I'm going to change my definition of 0.8. Remember, this is using, if you check it out, this is the Euler's method being implemented here. We used the previous y plus h times the slope. Well, what I'm going to do is I'm just going to say that this equals the new y value that I computed here. So that's kind of nice. So this just gets copied there. And now I have all the formulas I need. And if I scroll down until I get to x equals 1, and so the y value we get when x is 1 is 0.1713. Let's check in the book and notice that for improved Euler, when x is 1, we get the same value down here, 0.1713. Now next they want to try improved Euler with a step size of 0.05. So again, there's a couple ways we can do this, but let me go ahead to the spreadsheet and I can decide, do I want to save this? Yeah, I'll save this. So what I'll do is I'll copy everything I had over to cell I3. I guess I have to widen a couple of things, at least that y value. Maybe a few more columns we can widen. And I guess what we're going to do now is just change the step size to 0.05. And then we'll also have to run twice as many steps. And we should get a pretty nice result. So here I'm getting 0.1697 if I round. And that's exactly what we have here, 0.16968 for the improved Euler with 0.05. And you'll notice that these values are definitely closer to the exact value than the Euler's method. So even though there are extra computations that are made, we are improving the accuracy, and that's also, of course, shown here in the graphic. So I hope that this video helps you implement improved Eulers using a spreadsheet.